Good morning, everybody. This is Mr. Schultz again, Forensic Science 1. We're going to do the next set of notes. So we're going to get started right away. A little bit of a longer set of notes, but lots of pictures, so hopefully it won't be too burdensome, but we'll try to get through this pretty quick and see if we can get it done in 15-20 minutes, all right? All right, so let me do a couple things. First, here's our learning objectives, right? We're going to construct a timeline of significant contributions in forensic science, research major contributors to the field of forensic science, and then hopefully recognize and implement Lecard's exchange principle, which was actually introduced in the first set of notes. We talked a little bit about that, okay? So let me see if I can get to the next page here. All right, here we go. So your next assignment. I made this due next Monday, the 14th, and the reason for that is because you're going to be presenting part of this. So everybody's going to have to take about anywhere from 3 to 5 minutes and actually do a little presentation. So what's going to happen, and you'll have more specific details on the module, each of you will choose a specific forensic scientist, and you'll research his or her major contributions to the field. Some of them will be discussed in these notes. But others will be also on the paper. There might be some that, and there might be some that's not included on the notes. And if you know of one that's not included anywhere, feel free to ask me, and I'd be happy to let you use one of those gentlemen as one of the forensic scientists, as well as long as he contributed to the field in some way. So you're going to complete a mini poster or something called a Padlet on the scientist. I don't know if anybody's used Padlet before. But I will do a quick demonstration probably on how to do that for you guys Thursday or Friday, depending on which period you're in, okay? So, and then you're going to use that Padlet to kind of share with the class and turn in. So there's two parts to this. There's a presentation part, and then there's the Padlet that you're going to produce as well, okay? All right, so let's go ahead, and we're going to hopefully do this. Hopefully this will work, and I'll be able to click on some of these pictures, and we'll be able to bounce back and forth, okay? So this is a quick timeline. We're going to jump back to about the 6th century. That's typically where people think that forensic science kind of got its start. Certain aspects of forensic medicine were first documented in China. Around 1247, you actually had something called the Sun Tzu, which is the washing away of wrongs. This is a Chinese manuscript that provided methods to determine death by drowning or strangulation, right? And you could tell them apart, and you could tell them from the deaths caused by natural causes. And I will apologize. I'm giving you the abbreviated versions of all these. I'm not going to go into too much detail because one of the things I want you to do is do your own research about these guys. And if I gave you all the details, that would make the research a little too easy for you. Around the 1800s to 1810s, you have a gentleman named Arfila. This gentleman was one of the first experts to provide reliable scientific evidence in a criminal trial. He conducted academic studies in toxicology. He's sometimes referred to as the father of toxicology. Him and his associates developed the first chemical test to detect arsenic in a person, traces of arsenic in people's bodily fluids and tissues. And basically, he kind of established toxicology as a field, right? Kind of evolving out of forensic medicine. Oops, let me back up. Sorry, I want to keep bouncing back and forth so we can keep the time in mind. 1820s, 1829, same gentleman. After studying methods of blood and semen identification, he developed a series of chemical tests for semen identification, laying the foundations of some of today's routine tests that we still currently use. Moving ahead into the 1830s, we have a gentleman named Henry Goddard of Scotland Yard. Was one of the first individuals to use bullet comparison to provide evidence leading to the arrest of a murderer in a particular case. And I know this jumps around a lot, and we're moving through them pretty quick, but that's the idea, right? We've got a whole bunch of people to cover over here in a moment. Let's move on to Rudolph Virchow. This gentleman actually is famous for several things, especially in microscopy. But as far as forensics goes, he's one of the first to investigate human hair and determine that a questioned hair from a particular crime scene suspect was indistinguishable from that of a victim. So he was actually one of the first people to use human hair in presenting a case. Whoops. We'll come back and go back. There we go. Moving on, you got William Herschel. Herschel proposed the application of fingerprinting for personal identification. One of the first people to kind of start thinking that fingerprinting could be used as an identification purpose. That leads us into Henry Fowles. This is a Scottish physician residing in Japan, and he actually used latent prints from a crime scene to identify a burglar. So another person that was involved in fingerprinting. You have Lessard. He was at the University of Lyons. He was the first to associate bullets with a specific gun. So he was one of the individuals that kind of got ballistics started. And as a professor of forensic medicine, he was also one of the first to study blood spatter patterns. Jessrich is an Argentinian police official, established his own fingerprint classification system, so going back to fingerprinting. And he used it based on the data of his own research, as well as some of the different pattern types described by Galton, which brings us to Mr. Galton himself. Francis Galton published the first treatise on systematic identification of fingerprint in some 30 years after Fowles' first paper in Nature describing the use of fingerprints. So more headway in the fingerprint department. Baldhart in France. This gentleman worked as a medical examiner for the city of Paris. He studied probability models for fingerprints, bullet comparison, animal hairs, and blood spatter. So this guy is kind of a jack of all trades. He had his fingers in a little bit of everything. Mr. Arthur Conan Doyle. He kind of, this guy wasn't really a forensic scientist, but he contributed to the field because of some of his novels on Sherlock Holmes, right? So he published, some of his publications at the time suggested that soil collected on a person at a crime scene could be used as evidence. So he was kind of, you think of nowadays we have all the CSI shows, CSI Miami and all that stuff. This was the CSI of his times, right? Back in the 1800s. He was the one that was kind of bringing crime scene investigation and true crime type of scenarios into the limelight of his day. So, and then you have Hans Gross. Hans Gross of Austria. He furthered criminalistics by applying scientific knowledge and methods for the interpretation and analysis of physical evidence in crime scene investigation. He also established a journal dedicated to forensic science. And some of these people might come up again later on. Bertillon. This gentleman was an interesting guy. He actually developed one of the most significant and earliest personal identification systems. He was actually against fingerprinting. He thought his method should have been the one that was used, and it was called anthropometrics. Anthropometrics. And this system used a series of body and facial measurements to identify habitual criminals. Although he opposed fingerprinting, he was actually one of the first persons in Europe to use a latent print to help solve a crime. So he thought his method was better and should have been used in place of fingerprint, but he still saw the benefit of it and used fingerprinting as well. Oops. Get back there. There we go. Not sure why it does that. All right, moving on, we got Sir Edward Richard Henry. Again, around the same time, he was appointed head of Scotland Yard. He implemented his fingerprint classification scheme, which eventually replaced anthropometry in Europe and North America. And then you have Paul Jessrich. He acquired photo micrographs of bullets for comparison purposes, so he made more headway in the field of ballistics. Moving into the 1900s to 1909 era, we have Dr. George Popp. The first recorded use of botanical evidence was done by this German doctor who basically presented one of the first examples of this type of evidence in a criminal case. So he was able to use botanical evidence found on a suspect to link him to a crime scene. You have Hugo Marx, who furthered more forensic hair analysis. He was an official at the State Medical and Prison Medical Examiner's Office in Berlin. He prepared a dissertation on the value of forensic hair examination following a textbook published by the founder of the Vienna School of Forensic Medicine. Good old Edmund Lecard, we mentioned him a couple times, right? He came up with the Edmund Lecard's principle, but that's a little bit later. Edmund set up the first police crime laboratory in Europe, in Lyons, which is now the location of today's Interpol. This kind of like the international police clearing area. Victor Baldhart again, he was talked about earlier. He wrote a book, and I'm not going to even attempt to say this, right? But I'm going to say the translation of it, The Hair of Man and Animals. And it details the use of microscopic analysis to compare and observe morphological features of hair. Victor also published the first scientific article on the significance of bullet markings. So again, this is the guy that was kind of a jack of all trades. He's got his fingers in a little bit of everything. He's done a little bit of everything, even blood spatter and all that stuff too. Latz, Mr. Latz, actually he's famous. I mean, this is in forensics as well, but his big claim to fame is the ABO blood groups. He was the first one to kind of develop an antibody test that could identify a person's blood type, AB or O. And prior to that, even getting a transfusion was kind of a roll of the dice. If they gave you the wrong blood and they couldn't identify your blood, and they gave you the wrong blood, there's actually a chance you could have died from just the transfusion and when they were trying to save your life. But he developed a antibody test that helped figure out blood types. During this time, question document testimony was used in U.S. courts. That moves us up to the 20s, 1920, 1929. The first U.S. police crime lab was developed around this time in Los Angeles. We have Luke May. Luke May developed and applied analysis for tool mark comparison. So he kind of got tool marks started. Charles Waite. He cataloged information regarding weapon manufacture with the collaborative efforts of Goddard, Gravel, and Fisher, and developed this comparison microscopy for bullet comparison. So putting bullets on a comparison microscope and looking at them side by side kind of got their start with Charles Waite. Here's Lecard again. Good old Lecard. Made observations that almost impossible for anyone to participate in any activity without removing some soil or dust particles from the site, contaminating a person or their vehicle or any tools they might have had. And he developed the Lecard's exchange principle. Every contact leaves a trace. Make sure you know that sentence, all 5 words, capitalized, and the period. It will help you. Moving a little forward, 1930s, 1939, Franz Joseph Holzer. This is an Austrian scientist. He developed the absorption inhibition ABO blood typing technique that was to become used routinely in forensic science. So more on blood typing, kind of add it to this. Glaister published work containing 1,700 photomicrographs that show the structure of hair in humans and other animals in relation to criminal investigations. So he furthered hair examination. Right around 1932, the FBI crime lab was established. And that moves us up to 1940, 1949. Landsteiner first described the rhesus group, so the Rh factor in blood. So you know how you have A positive or A negative. That Rh factor is either there, positive, or negative. So he kind of added to blood typing again. And then in addition to that, you have Lewis, Kelly, and Duffy blood group systems were discovered right around the same time. Moving into the 1950s and 1959, we have Herschel. Herschel was the first to identify the polymorphic nature of specific component. Basically, it's this GC component that's found on the surface of blood, right? This will become a little bit more understandable at a later time. Also around the same time, we have the American Academy of Forensic Sciences was established. Okay, great journal, great organization. There's a link to the website, and I'll quickly pop it up here real fast, and then we'll go back to the notes. But they still do tons of stuff. They have tons of different links. They talk a little bit about all different things. They have the Journal of Forensic Sciences. All of that stuff is kind of linked in here. It's a great resource. I strongly suggest you use this as a possible resource to help do your research for some stuff that we're going to be doing later on in the year. Okay. 1960s, 1969, Culliford and Wraxall. These gentlemen came up with the polymorphic nature of erythrocyte acid phosphatase, or EAP, as well as the phosphoglutamutase, or PGM, and the adenylate, sorry, I always say that one wrong, cyclase, or AK, which determined which resulted in development of electrophoretic techniques. So these gentlemen basically helped get going what we use is, it's called electrophoresis, or the separating of proteins and or nucleic acids using a gel, which actually leads to a really huge development later on that we're going to talk about in a couple minutes, where we can actually separate DNA. In this case, they were kind of doing different proteins, right? Enzymes or proteins. All right, 1970, 1979, more isoenzyme grouping systems were discovered. So they have esterase D, or ESD, red cell glyoxylase, or GLOW. So these are, again, different enzymes or proteins that can be separated using electrophoretic techniques. That moves us into this huge jump. Mr. Sir Alex Jeffreys. Sir Alex Jeffreys and colleagues developed the techniques for profile analysis of DNA. In 1985, their achievements were published in Nature. As a result of collaborative efforts between British Home Office of Forensic Sciences and Jeffreys, the murderer of 2 English schoolgirls was identified using DNA for the first time. DNA profiling was introduced to U.S. criminal courts the first time, but admissibility was challenged, resulting in the development of some of the standards that we now have to use before we can use any kind of new techniques. And we'll talk more about that when we get into legal aspects of forensic science. Oops. Get back here. There we go. That leads us into the 1990s to 2000. Mitochondrial DNA started getting used. In September 1996, a new evidence tool was used for the first time in the United States courtroom. Mitochondrial DNA, or mDNA, was first introduced in a Tennessee murder prosecution against a 27-year-old gentleman named Paul Ware. So mitochondrial DNA can be used as well. And that takes us right up into the current times. Again, great journal, the Journal of Forensic Sciences. You have access to these. You're more than welcome to use this as a research area too. If you click on their website, it literally has article after article after article of different discoveries in forensic science, right? Strengthening the role of forensic anthropology, increasing the awareness of severity of female victimization, evaluation of performance of IND, ZN, and DFO on various porous substrates in Singapore context. So there's tons of different advances and articles and different things that you can research looking at this journal, okay? So a great resource. I would save that one as well. All right, that pretty much ends what we were looking at for today. So that should get us all caught up as far as this week's set of notes. Keep in mind the assignment is going to be important. You need to make sure that you do the research. Let me know if you have a different forensic scientist other than one of the ones that we're on the list or in the notes. So if you have somebody else in mind, you want to get clearance, just send me an email and I'll be able to tell you if it's okay, or I might ask a question, what did they contribute to the field, if I'm not too familiar with them. And if it looks like they are an actual contributor to the field of forensic science, I would be more than willing to let you research that person instead. All right, guys, have a great day.